Okay, today we're going to start working with real numbers and properties, and there's a lot of things that you've learned about real numbers, about irrational numbers, about integers. You've learned a lot of things about that in the last few years, and all of this is in your book if you need to review it. I'm not going to take a bunch of time to do it because a lot of it you should know. Integers are very important, however. They are the positive and negative whole numbers. Okay, they're one of the most important sets of numbers, the positive and negative whole numbers. And that's really all I'm going to say about that. They're going to use those terms, rational, irrational, integers, so on. But I really want to start talking about this idea of notation. And we're going to go straight to an example here. Let's say, for example, that you are asked to describe the given subset, and I think they're going to say describe it verbally, okay? Then graph, okay, then graph, and then they're also going to say state whether it is, I'll just put whether it's bounded or unbounded. State whether it's bounded or unbounded, all right? Now, let me make the bounded or unbounded thing real simple for you. If there is an infinity symbol any place, okay, if it's going to infinity in any way, then it's unbounded, okay? So what you're thinking of with unbounded is you're thinking of infinity, okay? So if there's an infinity on either the left or the right or on both sides, then it is unbounded. Let me give you some examples. What if it said x greater than or equal to 7, for example? Now it said to describe the given subset, okay, then graph and so on. So let's describe it. These are all the numbers what? Greater than or equal to 7. Good. Okay, so these are all numbers, and you can abbreviate some here, all numbers greater than or equal to 7. Like I said, you can abbreviate a little bit in there. Save yourself some writing. Now, graphing it, and again, don't take forever on this. We're just going to do a simple number line. There's 0, here's 7, okay? And we are going to include the 7, which means we color in the circle, and we're going to shade to the right, and that's good enough for me. You don't need to spend forever on these number line graphs. Is this thing bounded or unbounded? Unbounded. It is unbounded because this little deal right here is going to infinity. So this would be unbounded. All right, and I think you have the idea. Now, sometimes they will write this in what is called set notation, and you need to get used to this. Like that. -3, 8. And I don't know if you've seen this or not, but you need to know what this means. This is not the point, we're not talking about an ordered pair. We're not talking about -3, 8. We're talking about going from -3 to 8. This and this have different meanings. The square one means we include it. The round one means we don't include it. Okay? So it might be easier to kind of see this on a graph, and then maybe we'll rewrite it with a greater than, less than. I think maybe even in your homework they ask you to do that a little bit. So if I wanted to graph this thing, over here is negative 3, and over here someplace is 8. Now, it said that we do not include negative 3. So negative 3 is going to have an open circle. 8 is going to have a colored in circle. And then it's all of the numbers in between those two. Negative 3 up to 8, but we include the 8. So how could we write this with those inequality symbols, with the greater than, less thans? Well, x would be in the middle, right? And it would be less than or equal to 8, because we have to include the 8. And it would be greater than negative 3, like that, if I wanted to write that with inequality symbols. Does that make sense to everybody? Okay. Now, is this thing bounded or unbounded? This one's bounded. Good. Okay. Maybe we'll look at one more. Actually, I will put this one up here, and I'm going to pause the video and let you try to do this one on your own. Okay, so I'm pausing the video. Go ahead and try it. All right, let's see how you did. When you graph this thing, here's 0, here's 7. This is saying all of the numbers from negative infinity up to 7. So over here is negative infinity. We are going to include 7. So it's all of these numbers right here. Okay? And this one would be unbounded, right? This one's unbounded because it has an infinity in there, so we can never describe that. Now, how would I write this? Because you're going to have to do this tonight on a few problems. How would I write this with inequality notation? Well, isn't it all of the numbers less than or equal to 7? Okay. So you're going to have to do that translation a little bit tonight, all right, with going from, this is called set notation. Set notation, and of course this is inequality down here. All right. Now, let's review absolute value. By the way, if I ever go too fast, I can always go back a previous screen to let you get what you missed. Absolute value. I think we all know what absolute value is, but sometimes we forget what its technical definition is. Absolute value is technically the distance from 0. Technically, it is the distance from 0, and distance is never negative. Okay? We don't say, when I hop on my bike and ride to Hamden and back, which I do quite often, if I ride to Hamden, which is about, it's usually I got to Lake Rupert a little bit, so maybe that's about 8 miles out there. Okay? I don't say that I rode 8 miles there and then negative 8 miles back. That would mean that I rode nowhere. And I can tell you that if I've ridden to Lake Rupert and back, I usually know that I've ridden something. Okay? So I can promise you I've ridden 16 miles, 8 plus 8, not 8 plus negative 8. So what we say is that, if I'm talking about the absolute value of negative 3, it's always positive. All right? The absolute value of negative 3, how far is negative 3 from 0? 3 units. Okay? So, you're going to see some kind of review problems where they ask you to evaluate something like the absolute value of negative 17, which of course is easier than I don't know what. That's just 17. Okay, that's super easy. But then they might, give you an expression inside the absolute value. Well, if you have an expression inside, you need to do the expression inside before you change any signs. Okay? So negative 15 plus 29 is 14. The absolute value of 14 is 14. All right? Now, then they might give you a little more thought-provoking question, something like this. I know there's at least one of these in your assignment. They'll give you an expression like that, and then they'll say, okay, for x less than 5, something like that. So they're wanting to know, what is this? Okay. Well, here's the key to doing these problems. The key is looking at this right here, x less than 5. So all you need to do is pick a number less than 5. Right? Let's pick a number less than 5. How about 3? Okay? If I put a 3 in, okay, if I put a 3 in here and a 3 in here, I get the absolute value of 3 minus 7 all over 3 minus 7. So 3 minus 7 is negative 4, right? So this is the absolute value of negative 4 all over negative 4. So that is 4 over negative 4, which is negative 1. And wouldn't that be true for any number that I plug in? No matter what it is? Okay? Even if I plugged in a negative number, okay? If I plugged in like a negative 3, it would still work out the same way if this was a negative, because this is still going to be a negative number. It'd be negative 10, but the top number will be this, it'll all work out. This would be, what, negative 3 minus 7, so this would be the absolute value of negative. It still works out, okay? It's always going to be negative 1. So just plug in a number according to what they ask you to do, and then it'll be okay, all right? They might give you some simple problems like this and say, find the distance from A to B. If they say find the distance from A to B, it's as easy as it looks. Okay? Some of these problems are really easy tonight. We're just kind of getting back in the groove a little bit. Let's say that A is 78 and B is 13. Ooh, pretty tough, isn't it? What do? Subtract. Okay, this one is as easy as it looks. 78 minus 13 is 65. Okay, but then they might, mess with your brain a little and say, okay, A is negative 90, B is negative 43. Well, just do exactly the same thing. Negative 90 minus a negative 43, which is negative 90 plus 43, which is what? Negative 47. Now let me ask you a question, and this is one of the things that I want to confirm in the book. Now, what I wanted to check in the book was if they were, when they said find this distance, if they were meaning, like I just said, distance, like absolute value, is distance meaning it's never negative, right? And they are. So when I said that this is negative 47, okay, that is the difference there. However, since it's asking for distance, we need to take the absolute value of that number once we get it done. So it's 47. Okay, so make sure you do that at the end. Now the next thing, and we will even spend more time on this, but oh yes, we are big boys and girls in pre-calculus, and we need to be able to do fractions without a calculator. By the way, if you fill up the front of your page on your notes, just keep going on the back, just in case you're not sure about that. Let's start off easy. Yes, I expect you to do these without a calculator. 3/8 plus 9/8. If I'm adding fractions and they already have a common denominator, then I just add the numerators, right? I just add the 3 plus 9, and I get 12/8. Now, it's okay to have an improper fraction. It's not that painful, but how would I make that a mixed number? See if you remember that. Well, I divide the 8 into the 12. It goes once, and there's 4 left over. So this is 1 and 4/8 if I wanted to write it as a mixed number, which would be 1½ after I reduce it. We always try to reduce our fractions. Okay, that one wasn't real painful. But let's do one now where there are not common denominators, like 7/8 minus 5/12. Well, first rule that I always like to follow when I'm doing fractions is stack them on top of each other like this. And the reason I do that is because it makes it real easy to change my fractions off to the side so they have common denominators. How do I get a common denominator? Well, I could just do 12 times 8, right? But that's painful, working with 96. The better way is to take your denominators and count up by them. Watch. 12, 24, 36. Count up by 8s. 8, 16, 24. Do you see a common number? 24 is a heck of a lot easier to work with than 96. So the least common denominator, which is the one we always like to work with, is 24. And then I multiply across, and I ask, what do I multiply 8 by to get 24? It's 3. So I multiply the 7 by 3 as well, and I get 21. On the bottom, I ask, what do I multiply 12 by to get 24? It's 2. So 5 times 2 is 10. And now we're ready to subtract. So now I can do 21 minus 10, which is 11/24. Okay? Yes, we need to be able to do fraction problems without a calculator. And I'll answer why later, but you'll see why. How about multiplication? And this is a very quick review of fractions, but in reality you should have a lot of these skills already. 8 times 5, 6. Well, the first thing, I need to make this 8 over 1. Okay? That's first thing. Now, technically, you could multiply across and finish this problem. But one of the skills that you have to learn this year is that I have to be able to factor diagonally. What do I mean by factoring diagonally? Well, look at this 8 and this 6. Isn't there a number that will divide evenly into both of those? What is it? 2. So if I do 6 divided by 2, I get 3. And if I do 8 divided by 2, I get 4. And that's called factoring when you're doing fractions. Now look, now I can multiply across. 4 times 5 is 20. 1 times 3 is 3. And there's my answer. 20 over 3 is an improper fraction. It's ugly, but we could leave it that way, or we could change it into a mixed number. 3 goes into 20 6 times, which is 18, 2 left over. So it's the same thing as 6 2/3. All right. One last thing about fractions. Dividing. If I divide with fractions, it's the same thing as multiplication. I just need to remember to flip the second fraction. We call that the reciprocal. So when you divide by a fraction, you multiply by the reciprocal of the second fraction, like that. You change it to a multiplication problem, and then everything is like the last one. We're going to do factoring. Okay? So what's the biggest number that will go into 3 and 18? Isn't it 3? 3 divided by 3 is 1. 18 divided by 3 is 6. And then multiply across. 6 times 2 is 12. 1 times 1 is 1. The answer is 12. All right? And we are going to stop there for today.